Today I am going to tell about tangents of circles and properties of tangents and the solutions of exercise 10.1 from NCERT class 10. If you see the first case, here a circle and line are there and there is no common point for these two circle and line. And if you see the second case, here a line intersects the circle at 2 points. So here this line is called secant. So a secant is the line that passes through 2 points of the circle. And in the third case, you can see here, in the third case, this line intersects the circle at this point. So this is called a tangent, and this point is called a point of contact or point of tangency. So a tangent is a tangent to a circle is a line that intersects the circle at only one point. And we know that a circle is made up of infinite points, so we can draw infinite tangents for a circle. And at any point on a circle, there can be one and only one tangent. If you see this figure here, you can draw only one tangent at one point on the circle. And here, if you see these two tangents are parallel, so a circle can have two parallel tangents at the most. And if you see this figure here, if you draw tangents from an external point, you can draw only two tangents from an external point. Here, P is an external point, and you can draw only two tangents from an external point. Here, these two PQ and PR are tangents, and these tangents intersect these circle at these points Q and R. These points are called point of contacts, and this length PQ and PR are called length of tangents. So the length of the segment of the tangent from external point to the point of contact, this is the length of the tangent. And here PQ and PR are lengths of tangents. Now I am going to tell some properties of tangents. So you can see here, this is an external point P, and we can draw two tangents from an external point to the circle. And here Q and R are point of contacts, and O is the center of the circle, and R is the radius of the circle. And the first property of the tangent is a tangent to a circle is always perpendicular to the radius through the point of contact. So here this is tangent PQ and this is radius. So this is always R. OQ is always perpendicular to PQ, or PQ is always perpendicular to OQ. And here also PR is always perpendicular to OR. OR is the radius here. So you can write here OQ is perpendicular to PQ, and angle, so angle OQP, this angle is 90 degrees. Because these two are perpendicular, so this is 90 degrees, and OR is perpendicular to PR. So angle ORP, this angle is also 90 degrees. And second property is, here a perpendicular line drawn at the end of a radius is tangent to the circle. So you can say the same thing. If you draw a perpendicular line at the end of the radius, so if you draw a perpendicular line at end of the radius, means this point, then that is a tangent to the circle. So here, if OR is a radius, and if you draw a perpendicular line here, then PQ is a tangent. And the perpendicular line drawn, the third point is the perpendicular line drawn at the point of contact of a tangent passes through the center of the circle. Or you can say that if you draw a, first you draw a tangent, and if you draw a perpendicular line at this point of contact to the tangent, then that line passes through the center of the circle. So this is the radius. And the last property is the lengths of tangents drawn from an external point to a circle are equal. So here PQ and PR are lengths of tangents, and the lengths of tangents from an external point are always equal. So here PQ is equal to PR. So these two lengths of tangents are equal. Next, see this figure. Here, these two tangents and the radii of the circle form two triangles. And in triangle POQ and triangle POR, in these two triangles, these two are right angles, 90 degrees. And this is hypotenuse, this is common. And these two radii are same. So, by RHS congruence rule, we can congruent these two triangles. Triangle POQ is congruent to triangle POR. So once these two triangles are congruent, we can equal the corresponding angles. So we can equal these two angles. So angle OPQ is equal to angle OPR. So these two angles are equal. Therefore, we can say that OP is the bisector of this angle QPR. Or we can say that the center, this is the center of the circle. The center lies on the bisector of the angle between these two tangents. And next one, here these two tangents and these two radii form a quadrilateral. So we know that the sum of the angles of a quadrilateral is 360 degrees. So angle P plus angle Q plus angle O plus angle R is equal to 360 degrees. And here these two angles are 90 degrees. If you know one of these two angles, you can find out the other angle by using this formula. Now I am going to tell how to solve exercise 10.1 from Circles chapter from Ncert class 10. The first question is, how many tangents can a circle have? We know that we can draw infinite tangents on a circle. You can see from this figure. You can see from this figure, you can draw, because the circle has an infinite number of points. So we can draw infinite tangents on a circle. And next one is fill in the blanks. The first one is a tangent to a circle intersects it in dash points. So we know that a tangent to a circle intersects it at only one point. See, at only one point. So this is one. And second one is a line intersecting a circle in 2 points is called a secant. We know that a line intersects at 2 points. This is a secant. And third one is a circle can have dash parallel tangents at the most. We know that there are two parallel tangents you can draw. See, these are two parallel tangents you can draw like this. So answer here is 2. And fourth one is the common point of a tangent to a circle and the circle is called dash. So the common point of a tangent to the circle. So we know that that is point of contact. This is the common point for the circle and the tangent. This is point of contact or point of tangency. So here the answer is point of contact. This is third problem. A tangent PQ at a point P of a circle of radius 5 centimeters meets a line through the center O at a point Q, so that OQ is equal to 12 centimeters. So length of PQ is, here some options are given, we have to find which option is correct. So here a tangent PQ, so this is the tangent PQ at a point of P. So P of a circle. So the point of contact here is P, and the radius of the circle is 5 centimeters. So OP is equal to 5 centimeters, meets a line through the center O at a point Q. So here OQ is given, that is 12 centimeters. We have to find PQ, that is tangent length you have to find. So here this is a right triangle because this angle is the radius is always perpendicular to the tangent. So this is 90 degrees. So this is 90 degrees and hypotenuse as per Pythagoras theorem, OQ square is equal to OP square plus QP square right here. Then OQ is 12 square is equal to 5 square plus PQ square. Then PQ is equal to square root of 12 square is 144 minus 5 square is 25. So that is square root of 190 centimeters. So answer here is D. This is last question. Draw a circle and two lines parallel to a given line such that one is a tangent and the other secant to the circle. So, for example, this is a circle and this is a given line. We have to draw two lines which are parallel to the given line. One is a tangent. We know that a tangent is a line which intersects the circle at only one point. So, here this is a tangent. This is parallel to the given line. And this is a secant, other line is secant. So we know that a secant is a line which intersects at 2 points. So, and which is also a parallel to the given line. So this is secant.